Sir, taper as in?
Okay. তাহলে আজকে আমি I will not intrude that subjects too much, but this is one area where the little knowledge I have I can share with you, that how to choose the right kind of material. By the way, I will get back to this point again, but since I have 1 or 2 minutes time, how many of you have precious or semi-precious stone in your rings or armlet or wherever? Is there anybody among you who wears the precious stones like ruby, sapphire,
Sir, emerald.
emerald? You have?
My father wears an emerald ring, I believe.
Okay. So I slowly start. Well, I upload my material. Can you see it?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So we start. Uh, Welcome to this class. I put it in the PPT mode. Uh, these are the pictures which I showed in the last class and stopped at this point. Two basic things I discussed in the last class. One is how the river erodes or remove materials along its path. Sometimes this process produces beautiful landscape, and in most cases they create a lot of trouble for the constructions uh, which we require for communications. So once we are done with the first previous lecture, so obviously the question will come that is it only the momentum of the fluid, I mean momentum of water, or the strength of material also has a role to play. Your fluid may have a specific Reynolds number, may have a specific velocity, but some materials will erode faster and deeper compared to some other metals. So what are the guiding factors? So today I will discuss a part of it, and then again I come back to the fluid property, and again we move to that because these things are absolutely interrelated. So So I begin with these things, that what actually controls the strength of materials. It depends on three properties, and I also made a note on this in the space below, that I'm not quite convinced about these two things, because mechanical and physical properties both deal with material which do not change their composition during the interactions. So these properties should be clubbed under physical properties. But from your viewpoint, this classification possibly is required because these are the properties which actually are shown by the matters when they are under stress. But these properties play a role even without a stress, or this property may show up even without a stress. Suppose you have the density of a material. It doesn't matter whether you put pressure on that, you increase the temperature. You may say that why you are saying so, because volume expand, mass remain constant, so there will be a change. But in solids, unless and until the magnitude of change is big, our density remains more or less constant. And if you deal with the surface materials, which you actually deal, the civil engineers only deal with the materials which are on the surface of the earth. So in this condition, these climatic fluctuations or variation according to geography, that doesn't really change the density of it. So these properties remains more or less constant whether you stress it or you don't stress it. Theoretically they do change, but practically they don't change. But this property, the chemical property, this is very difficult to define, because chemical property is basically is the response of a material. You all know the thermodynamics. You must have read in the high secondary class that I mean every substance try to reach to a level where it has minimum Gibbs free energy. So driven by that principle, there are chemical reactions always. When we have a chemical reaction, all the physical properties what we discuss will drastically change. We give some names like rusting of iron or decomposition of rock, etc., etc. But basically, these are negative words from the viewpoints of the mineral science or material science. Basically, what happens during a chemical reaction, the initial bonds within a substance, they break and then they reassemble into the form which has the minimum Gibbs free energy at the ambient physical condition or the chemical condition. So the moment the iron starts rusting, the rust is a mineral. We are calling it rust because we want to focus on steel, or we want to steel. Really, actual steel doesn't rust, but for iron, it does. So since we want to focus on iron, so we call, this is rusted and there will be a problem. There is nothing called rusting. Basically, the rust is iron, ferric oxide, and water. They combine. So in the iron, we have just Fe. And then they reacts with the atmosphere, this oxygen and the moisture, and they, just a moment. So the moment iron is converted to this mineral has a name. It doesn't have a name rust. Its name is limonite. hydrated ferric oxide, immediately the properties of this mineral is completely different from iron. So whatever measurement you do, whatever experiment you do with iron will not be valid if the iron starts rotting. Similarly, if a rock decomposes or start decomposing, all your strength of matter will completely change. Decomposition means a new set of minerals are formed. I did a mistake. Possibly one of you should regulate this thing. Okay, so today I shall be discussing these parameters which are marked as green color. Okay, so as we proceed in the next classes, I will try to cover most of the things which are of importance for your studies. So let me begin with these two things. One is hardness, another is abrasive resistance. You look at that, this is under mechanical properties and this is under physical properties. And never forget, hardness is the key thing to understand the strength of material. Hardness is basically measures the scratchability of a material. That means if you have material A, which can make a scratch on material B, then the B will have a lower hardness than A. So this is the general principle. I will discuss why does it happen, but general definition of hardness is this. And abrasive resistance is basically the same thing putting in a different way. Abrasive resistance means if you try to do that, if you try to rub one thing over the others, then how easily it will make scratches. Scratch makes scratches means it removes materials along the scratch. The scratch can be tiny or scratch can be big. So these two things are very much related. So let me begin with this hardness. How this is measured? How do I know the hardness of a material? Remember that in 1812, this is one of the most innovative work in science and technology. Not all work are innovative. Still now, whenever people deal with material, be it natural, be it synthetic, it primarily depends on these things. What Morse did, that he took a set of minerals and used the scratching principle and developed a sequence. So if you take gypsum, this gypsum will make a scratch on talc, but gypsum cannot make a scratch on calcite, and so on and so forth.
Sir, is the
The,
scale a logarithmic scale?
pardon? Come
Is
again?
the hardness scale a logarithmic scale or is it a normal scale?
No, it's just a number. I'm coming to that. It's just a relative part. Okay. So it is from 1 to 2 is not the same as 9 to 10. And this is not a linear scale. So actually what happens once you have this thing, you see the diamond on the top. That means diamond will make scratch on each and every materials. And this is the hardest known material in the world. Now, in order to measure the hardness, you cannot carry all the 10 minerals. It is impossible. So what he did, he actually suggested some materials which you can easily carry. For example, fingernails. This is with you. The fingernails, according to this sequence, has a hardness 2.5. That means it can make a scratch on talc, it can make a scratch on gypsum, but it cannot make a scratch on calcium. Similarly, the copper penny, it has a hardness 3.5. Knife, glass plate, 5.5. So, using fingernail or copper, you cannot make any scratch on glass. So, those who wear spec, when you rub it, it is advised that instead of rubbing for cleaning, you soak it with water, because some of the fine particles which deposit on that is quartz, which has a hardness of 7. So once you rub it, immediately you get a scratch. And I have several scratches on that, because I do not know how could it happen, but it did happen. So please do not clean your spec just by using a cloth and rubbing it dry. First you soak it in water. Once it makes a scratch, it remains forever. So this is how it is done. Unfortunately, this should come later, uh, but it is there. It's my problem. I will try to fix it. Okay. So if this is the sequence, you know that what is the, where does a particular substance lie? Now, the question you ask, that is it logarithmic or linear? Exactly not. Copper penny, can it be 3.2? Can it be 3.7? No, you cannot do that, because that precision you don't need. So since it is smaller than 4 and greater than 3, so we arbitrarily put it on 3.5. All the materials are actually arbitrarily uh, calibrated against this tendency. In fact, you should not go beyond this one, because I mean these are too tough to be present in the rocks or in other synthetic materials. So this is the basic concept of that. Now the question is that, does one mineral has a unique hardness? Answer is no. The hardness actually is caused by the bonding within the material. You know, the bond strength decreases in a very general way, decreases in this direction: covalent, then electrovalent. Electrovalent and metallic are almost the same, and then the weak van der Waals bonding or hydrogen bonding. So it moves in these directions. So if a material has uniform bond strength in all possible directions, it will have one hardness. But if a substance has different bond strength in different direction, which is reality, not only in minerals but also in rocks or synthetic materials, that they are not isotropic. That is, they do not have same property in all directions. In that case, your hardness will be different. I give you an example. This is a mineral called cayenne. This aluminum silicon oxide. This is a beautiful color. And the kyanite, the name of this root is kyanos, which is a Greek word meaning blue. And the French people, the French language, took this kyanos and called it cyan. And you know that CMK colors is, C stands for cyan, which is blue, cyan, magenta, and yellow. CMY, yeah, yellow. So this is how the kyanite is because of its color. Now, along this length, you have a hardness 4.5 to 5.5. But across this length, you have a hardness much higher, 6.5 to 7. The moment you have this, immediately you can predict this mineral or this material has weaker bonds in these directions, but stronger bonds in these directions. Now, every material, including minerals, they are three-dimensional. In crystallography, you need to define the coordinates in terms of three axes because it is three-dimensional. What is the convention is the longest direction is taken as c-axis, and then the one which is parallel to you is the a-axis, b-axis, and one towards you is a-axis. Sometimes you can change this b and a depending on your requirement, but general convention is the elongation direction is c, parallel to you is B, and A is coming towards you. So basically this is the C directions, and you have the lowest hardness. Now what I was trying to discuss in the small words before my class, you may not wear a gemstone, but you must have seen people wearing gemstones. And possibly you are aware of the myth that the sapphire, which is Nila in Bengali and Nilam in Hindi, this sapphire has the myth goes like this: the sapphire can extract the favors of the planet Saturn, and that's why those who wear the precious stones, one of the target is this thing, sapphire. And the merchants know this psyche, and this sapphire is very, very expensive. Now, from where you will purchase? So one of you said that his father wears aquamarine. This is what you said, huh? I can remember, Baba, your name. Hello, hello. Who said that his
Yes, sir,
father?
you're audible. Oh, yes, sir, I
Yeah,
said.
yeah,
Emerald.
yeah. Your name better?
Avi Viswas, sir.
Avi. Huh? So aquamarine, the way aquamarine is a precious stone, Nila is also a precious stone. Now, when you have expensive things, there is always a possibility of counterfeit. Now tell me, I show you two pictures. Tell me which one is sapphire. You
Uh, I cannot say that, sir, just looking at two same
So
pictures.
both are copy paste pictures.
Yes, sir, both of them look the same.
it look the same if you go to the market, it will look the same. It will
So you
look
can
the
try
same.
Sir,
breaking
you
it
will
with
do
a hammer.
scratch test, sir, scratch test.
Just a moment. The scratching, well, the jeweler person will not allow you to scratch.
Hmm.
So if you go for a sapphire in a jewelry shop, big jewelry shop, and they may say that, well, this stone, this is sold in carat. This is 5 carat stuff will give you, let's say, 20,000. You said, 20,000 impossible. I cannot. I cannot. And maybe more. I mean, I really do not know the market rate. It could be several tens of thousands. So I said, no, 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 it is not possible for me. Then he would say, sir, we have a cheaper part. If you can take them, we can give. So they will go for a half the price. Now they will show it, and you will just, move it like this, and, hold it in the light. Everything remains the same. But in reality, the things are like this. This one is sapphire and this one is kyanite. Exactly same. Exactly the same. You have practically counterfeit for all the expensive gems. All. Most of the people, even the jewelers, They are duped by these things. Unless you actually, then what do you do? Well, on a lighter note, I may say that bring it to me. But I don't have the improvement and I cannot tell you which one is the real one. But the thing is, I can direct you to a place where you get a certificate. That is the government, it's a big government office, Geological Survey of India, and there you have these things. And if you give this, they will give you a certificate because they will do many tests and they will tell you whether it is a counterfeit or a normal thing. It is my guess because they have a gem division. My students are working there for a long time. They say, sir, 80% of the people who come to us, they wear counterfeits. That is not real. Even if they purchase from a big shops, jewelry shops.
But sir,
So
it's kyanite cheap.
it's much cheaper, much cheaper, much cheaper. Maybe one third of the price.
Sir, is there any difference between sapphire and kyanite?
Physically, visually, no. Visually, no.
Okay.
Absolutely no. So that is the reason if you go for expensive things, go to Geological Survey of India, the gem division, they will do some testing, non-destructive, because you can destroy the thing. Okay, non-destructive test, they can immediately tell you whether this is a counterfeit or not. Okay,
So sir, whenever we buy stone, should we also ask for a certificate?
yeah, certain, they will give the certificate. No, no, that certificate will not help. Suppose ex-jeweler give you a certificate. What does it mean? You are wearing a counterfeit. What
So
does
then,
it mean?
sir, how do we recognize? How do we
You
know
go
the
to
real thing?
geological survey, pay some fees, 100 or 200 rupees, and they will provide a certificate whether that is sapphire or not.
But sir, that will happen after we buy the thing, right?
No, you may say that big, no, very expensive gems should not be purchased across the board. You must tell them that either you get the certificate from geological survey or send someone who gets it. I will pay the fees. So you are putting 30,000-40,000 rupees, and you can easily spend another couple of hundreds to send a person to that place and get a certificate. So that is the general principle. But it is up to you, I mean, whom you will believe. But anyway, just a moment, somebody must be waiting. So, so we move on. Now we go to talc. Talc looks like this, very similar to marble. And all the curios what people purchased from Jabalpur and sold as calcite, not in the big shops, but by the side of that big falls, are all talc. If you touch this material and get a soapy feeling, and these people are so intelligent, then they put a lacquer on the different statues and these things, and the common scene is you see heart shaped they will call marble heart shaped things, and would ask you, sir, if you are interested, I will put your name or the names of your loved ones on that. And this is the common human habit to see his name engraved on rocks. So many people fall in trap, and basically that trap is talc. Just a moment.
Many times tell that talc soap or talc
Yeah,
is connected to
yeah.
soap.
Talc, I'm coming to this point. Talc otherwise is a very industrial friendly materials. A lot of things are made out of that, but surely it is not very expensive. I tell you. So in talc, you see these layers. Usually, I mean, there are plenty of talcs within the marble. I will come to that. And in talc, it is so soft again because of the structures. If I see the structures, internal structures of talc along that, this is the C direction and this is the C direction, you see the stacking. So one sandwich has one MgOOH layers, and I have written down this thing, so you don't have to worry about that. This is magnesia oxygen weight bearing layers, and this is SiO bearing layers, and they form a sandwich, and this sandwich is hard. Not very hard, but reasonably hard. So these layers are actually separated by, I mean, they are actually attached to each other with very weak van der Waals bonds. The moment you use your nails, actually you split these layers along that. And the bond is so weak, the moment, even if you rub, then one layer will come out because of the very weak bond here. In mica, you must have seen mica. The reason why you can take out one scale is just because of that. Mica has the same structure. Same structures, you have one sheet and two sheets are linked with a very weak bond. So you can just peel it off. But unlike talc, mica sheets has tremendous strength. You cannot tear it off. If you pull it like this, you have to put lot of effort, and that's why the mica is used in different industries because of its strength. But talc is not so. Only few industries where you have this talc, and because of these things, because of these weak structures here, as I said, the mineral tend to split along this, and this part we call cleavage. Cleavage are basically, they have a crystallographic orientation. In this case, the cleavage is perpendicular to the c-axis, and the cleavage always is, it is not a fracture. If you take it out one layer of mica, you always see a smooth surface. Here, if you take out the talc, the surface will be smooth because of this cleavage. This is the inherent or intrinsic property of the material. So a rock which has more talc will be very weak rock because the rock strength is basically aggregate mineral strength. Of course, there are some issues of the way they are locked, but it's aggregate mineral property. So this is what we call cleavage, and it is not necessary that one mineral will have only one cleavage. Not all mineral have cleavages, but mineral have cleavages, but that can be 1, 2, 3. Now, what is 1, 2, 3? If the cleavages are parallel, they will be considered as one set. So all the cleavages, this can be billions of layers or trillions of layers, but they are one set because they have one crystallographic orientation that is perpendicular to the C. That is the direction of elongation. So they are considered as one set of cleavage. So when I talk about 1, 2, 3, that means if a mineral which has two sets of cleavage, you can see their intersections. If you have three sets and you have three different directions, so this is how we actually measure, identify the sets. Now, in this small scale of hardness, quartz is the only mineral which doesn't have any cleavage. They don't split into sheets or blocks. All other minerals, including diamond, they develop weak to strong cleavage. So that's why the rock which is rich in quartz are extremely tough. Now, if I ask you, what can you make out of this statement that quartz doesn't have any cleavage? What does it mean? Can you tell me what does it mean?
Sir, there is no depression in the structure.
Yeah, I mean, it doesn't have any weakness in any direction. They have uniform structures in all these direction, and but uniform bond strength in all possible directions, and the bond is very strong, and that is covalent. I mean, in pores, the covalent bonding is preponderant. Of course, there are some electrovalent part, but covalent bond is preponderant. And that is the reason why pores is so strong. And that is the reason why the sand you get in the riverbed or in the sea beach are made mainly of pores. Because the rock breaks, the surface water takes those materials to rivers, and the rivers takes it to ocean, and the rock initially may have this and some other minerals, but among them the ores is the toughest, both physically and chemically, because it is very difficult to break the bond. That's why ores is extremely resistant to chemical alterations. And that's why in the process of water going towards ocean, only core survives. And that is a big issue for the civil engineers. I will discuss why it is so. So they don't have cleavage. Then if you hammer it, what happens? Hammer it, you have these things. This is called fractures. In fact, all the minerals can develop fractures. What is the difference between cleavage and fractures? Fractures is the moment it splits, but the surface is irregular. That means they are not formed along certain crystallographic planes. Or if the minerals have cleavage, if you hammer it, it always tend to split along the cleavage, and that's why you always yield smooth face. If you hammer calcite, you will always see it splits, but each of the split will have very smooth surface. But for words, you will always see these things very irregular, but this type of things, this is known as conchoidal fractures. The term is coming from this Greek word conchoid, means this curvature in shells. This is a conchoid in Greek language, and you see the fractures exactly similar. Sometimes you have these radial cracks. You see, some shells also have radial things. All the bulletproof cars or very good cars have windscreen. If a stone hits or any material hits on the windscreen, they tend to split in this fashion because they are very homogeneous. It's not coarse, because it's very expensive, but they make they are made up of some glass which has properties very similar to quartz. If a materials have uniform bond strength in all possible direction, it will only produce this kind of fractures. So in the broken screen, you must have seen the photographs in all the fractures. So just like this, just like the cowboy, which is something very similar to this. Anyway, so this is the basic difference between fracture and cleavage. If you see that you hammer a rock or any material, it splits into this. It can happen to mineral, it can also happen to rock. If you see this thing happening, always assume that it has strong and uniform bonding in all possible directions. Otherwise, they would split to form very smooth plates. So now the mineral 3, because this is not from Jabalpur, but from mines of Andhra Pradesh, where you can see the calcite, and usually the big crystals of calcite is just like this. And here, if you can focus on my photograph, you can see that in all possible direction you have the stripes of these weak planes. You see, it is coming like this, it is coming like this, but this one is fractious because this is uneven places, but usually splits into smooth planes. You see, this block has gone out. So individual block has very smooth planes. It's just one set of cleavage here, another set of cleavage. In fact, calcite has three sets of cleavage. You need not remember, but what I want to see, you see two sets of cleavages are meeting at very high angles. But it's the calcite looks like this. The thing is, what is this mineral? Looks very similar to sapphire. Well, the jewelry market is really murky. If they have the right guess that these people do not understand the stone, that they have come here not to purchase a beautiful stone, but to satisfy the astrologer, immediately they will give you this thing. Again, you have no clue that this is not sapphire. This is very cheap. Of course, this color of this mineral is rare. This mineral is, well, if I just, this mineral is apatite. Number 5, usually apatite is green color or colorless, but in some cases you have blue apatite. It's very cheap because in gem market, stronger the bond, more expensive it is because it has resistance to external force, and you have to pay for that. The durability. So if you take an apatite and if it falls down, it will immediately split into cleavages, and suddenly you realize your sapphire has gone and the power of Saturn has also gone. Those, I mean, I'm talking about those who believe in astrology. I'm not a person who believes in these things because I deal with this material. Okay, but it looks quite nice. I have no problem to have a ring like this, but not for astrological reasons. Well, coming to the calcite have a very funny property. I really do not know whether you have studied the double refraction phenomenon. In your high secondary, have you studied?
Sir, can you repeat?
Have you studied the double refraction phenomena of light?
Said the ordinary day and extraordinary day.
Yes, sir, we have.
Right. Yeah. So this is the property of calcite. In fact, most of the transparent minerals that you deal in nature are basically like this. So one of the rays follows Snell's law, and another ray does not follow the Snell's law. And that's why if you just rotate it a bit, one person will stay static and another person will rotate around that. And the image for the rotating ones are extraordinary. It doesn't follow Snell's law. So, and the reasons why this calcite, I mean, transparent calcite is very, very expensive because all the good microscopes are made up of this. Polarizing microscope are made up of this calcite. And the reasons why you see these beautiful smooth planes is because of the cleavage. If there is one set of cleavage like this, another set of cleavage like this, third set of cleavage like this. But in a good quality calcite, you really cannot see the cleavage that distinctly. So this is the calcite and apatite. Now, in nature or in yoga, you don't deal with mineral. You deal with rocks. We are interested to know the strength of the rocks. But rock consists of minerals. So let us put some of the common rocks which we see in nature and which actually used either as a pavement to anchor some structures or can be used for building materials. So one rock is quartzite, which is more than 90% is made up of quartz. No wonder that it will be very, very hard. And then the two most common things in nature, this granite and basalt. In geology, it is a general name, and I have described what does it actually mean. It's a black color rock, and this is a light color rock. And granite and basalt are two common rock. You see their strength is quite hard because it consists of, for example, granite is basically made up of quartz and this orthoplates, which is potassium, aluminum, silicon, oxygen. So mostly made up of this thing. So it is weaker than quartzite but stronger than granite. So whenever you think of erecting a dam or a road, use these three rocks as anchors. Don't go for marble or for some other rocks because these are the common rocks. So just choose your basement or building materials there. Just a moment. Next day, email Shogi he will operate. Every time I'm getting little distracted. Okay, so these are the common rock, and according to the hardness, you will also see that it is broadly classified into three groups: one is soft rock, medium rock, and hard rock. So, depending on your requirement, you choose which rocks or which material. It's not only the natural; all your synthetic materials should be calibrated according to this. So just use it the way I have described. Now, the abrasive resistance. If there is a flow, for example, you have a basement which may have sediments or may have a rock, and water is flowing over that, water doesn't flow alone. I will, in the next few slides, I will show you what happens basically. It takes the materials either as the rolling particles or in suspension. So the rolling particles, basically when the water moves over the rocks, this material also moves over the rocks and they produce a strong, frictional effects, and some materials are removed in the process. Otherwise, simple water cannot erode a material. Whatever may be its Reynolds number, it cannot make any groove. Whatever may be its Reynolds number, but the Reynolds number is required the way the fluid will move, those particles will also move in that way. So that is the killing things. But before that, instead of water, let us consider ice. Ice flows, that along the slope of the icy mountains, there are avalanches, or even there are other ways where the ice moves over the rock. Then what it does, it takes all the broken rocks in front of it or beneath it. So when it moves, basically they rub this material they carry over the materials. Otherwise, uh, ice per se cannot abrade any material. But the material it carries along with that, they are quite hard. And most of the cases, I said, is quartz. So they abrade the thing. So one of the features, this picture you can see that is from Canada, is this long grooves, that is materials are eroded. And these are explained, and the polished surface. River cannot polish a surface. And if you said these grooves are also available for river boned things, but get the polished surface. So when you have the polished surface and these groups, inferences glacier moved over there. Hundred million years, and we have lot of evidences of this type of groups of aberrations. This is natural aberrations, and one of these arrow will indicate the flow. No wonder, because if you have a scratch, and that is the reason why in your house, when you try to shift the heavy material, what we do, we usually lift and put it some jute bags, and then slowly push it, because you reduce the coefficient of friction. Otherwise, the floor will get the scratch if the material what you are dragging over it has higher hardness than your floor. Usually that is the case, and that's why you see the scratches. The moment you put a jute bag below that, you actually reduce the coefficient of friction, and since the rubbing is least, your floor is escaped. But here nobody can put a jute bag below the ice, so the rock has to suffer. So this is how the aberration occurs in nature. Now what happens in the fluvial system? As I was telling, that when the water moves and moves very fiercely, there are two types of materials they carry. One is called bed loads. Bed loads means it moves along the bed, and this is the most dangerous thing for the construction. As I said, that because of its strength and chemical durability, ore survives the most. So basically, the river takes along the quartz rich material. And the size of the material, if you consider the composition fixed, let's say quartz, the size of the material they will be carrying depends on the Reynolds number and the velocity of the fluid. So the heavier ones, the bigger ones only rolls. Slightly finer ones, they make a little jump, again comes to this. So these two are called bed loads, and the very fines are there, which are known as suspended load. And you see the color of the Ganges in Kolkata is murky, I should say. It is murky because, I mean, the river doesn't have the adequate strength to carry these things. They only carry the suspended load. And that is the reason why, I mean, it's because of the suspended load, it is this gray always. But if you go to the upper reaches of Ganges, you see the clear stuff, absolutely the clear stuff. So this is how it moves, and just remember that when it crosses 2000, or when it starts developing all those ADs, what will be the behavior of this material? They simply scrap out whatever they get on the way.
Sir,
Yes, sir.
in the previous image, in the diagram, you have written saltation and traction. Is the whirlpool arrow referring to traction?
Yeah, it just moves like this.
It
It's
is.
rolling basically.
So, what is the difference between saltation and traction?
Saltation, it is thrown in the water and then comes back.
Okay.
Okay.
Hmm.
They're thrown in the water for a few seconds and then they come back. And again making a leap and come back. But this one doesn't,
It is
snap
continuously
its
moving.
ties. It doesn't snap its ties with the basement. It only rolls. The bigger ones actually rolls.
Okay, sir.
Okay, so you can
Okay.
throw it. Well, in some fierce rivers and this is a time of flood, even the big grains can be thrown in the water, but most of the cases they get rolled. They move by rolling. Now that is what I was showing. The moment you make eddies, remember that you have pores here. They just put out material because quartz is harder than most of the material we know. It not only causes this depression, but also remove materials from these things. All the synthetic materials we know of have lower hardness than quartz. That is the reason why, unless you maintain these things, no pier of a bridge or a dam can stay forever, particularly if the rivers become ferocious during the flood time. This is a big, big problem for the civil engineers. And the reason is not only water, but it is those traction and saltation loads. Just to give you an example how big the materials can be, in some riverborne rock have this size of grains. You see, this is a pencil, and this is found on the bank of Narmada. I will show you the place. So imagine the size. It is moving almost with the velocity of the river, almost. And if this make an impact with any structure on the way, what will be the fate of these structures? And if it moves like this, so whatever you do, just blown away, just blown away. And this rock where you have big grains known as conglomerate. I have explained these things, so you will not, bother about the names. Basically, the sediments what you see in the rivers or oceans, they are divided on the basis of an assumption that they form a sphere. For this grain, even if it is not a sphere, but you can imagine a sphere like this, and you measure the diameter of the sphere. That is the long dimension of the object. And on the basis of that, we call someone pebbles, someone cobbles, one boulders, and some sand. Okay, the sand may be smaller, but I tell you, if it rubs continuously the surface, and the surface is gone. So, in sedimentology or in geology, what we do and whom we call a conglomerate. I will not ask any question on that, but just to complete the story. So, this is the grain size of the sediments, and this is the proportion. This is divided on the basis of this proportion. We give a name to the rock. Mud is basically this part, this particle size. Gravel is basically this part, and blue part is sand. Okay. So when we call sandstone, that means it should be in this region. When you call it a conglomerate, it will be here. Okay. Now look at this part again. Quartz, it must be part of the rock. Now breaking of rock cannot produce the smooth surface. So it became smooth because they traveled a long distance. They abraded the basement and itself got abraded. How itself can get abraded? Because it is a very high hardness. there are collision between different waves. That makes the sharp edges round. Okay, so this is how we classify the rock. Just to give you an idea, what could be the size of those pebbles which moves almost slightly lower velocity but almost at the same speed of the flow. Mind-boggling. Now you can understand why the pillars fall during the time of flood. It's not water. It's this material. They hit. What do you do? You can do nothing. In Barna, I will not get into your subject, but just to tell you that this equation of continuity, you know that the flux of fluid or the flow rate of fluid is AV, is area times the velocity. Okay, so if the area remains constant, then velocity becomes proportional to Q. Now during flooding, you have an enormous increase in Q because you have lot of water are coming. So obviously the velocity will increase proportionally, even if the channel remains the same. The moment you have this velocity, then you fall in trap with this Reynolds number and all these eddies. And all these eddies carry along with it these materials. It's just like bombarding a place. And that is the real reason why most of the pillars basically collapsed. Possibly it was eroded before gradually, but the final nail was inserted during the flood. So this process or the processes are linked. Now, well, as of until this slide, what I showed before and these things, you had to believe that, well, this is the process. The SAR is showing, but I didn't show that it is happening. I didn't show you. So let me show you that these things happens. You can see these things. If you happen to go a beach, you will see these features, these groups. Basically, during high tide, water moves up the slope in the beach and then goes back. And when they go back, they carry along with the loose sands. And if the loose sands finds a clearish part, which is almost very close to the waterland interface, you will always find these things. This loose sands actually drags along that and creates these things. In the sandy part, you will not see this. If you move towards the ocean or sea, then you must have seen these features. Sometimes these features appears like surreal pictures. Now, why such colors? I asked many people that what is these things? The question I faced. I mean, if you know the backdrop and that's why you know that this could be the process. Suppose I don't give you the backdrop. I tell people that how is the pictures? Please believe me, most of the people say the painter is fantastic. Some people say, well, it looks like a painting here, but this elevated portion, maybe nowadays there are composite form of art where you have some, elevations here and there and some painting. But if I remove this part and only focus on these things, anybody will confuse it with a painting. This is a forest like thing. Now, how it happens? The beach from where I have taken this picture is a beach very close to Chadipur. Here, the beach has a interesting characters. The beach sediments are layered. The upper layer is quartz, which appears yellow, and this was followed by a lower layer which is made up of oxides, ilmenite, FeTiO3, which is also very resistant. It's not as hard as quartz, but comes very close to that, is 6 plus hardness. So because of the stratification, the water flowed along this. Sometimes it scooped out and exposed the lower unit. And that's why you see these beautiful pictures. But these are the features which actually shows that flow does abrade the material. In some rocks, well, here I must say one thing I forgot to mention, that these are the structures which are formed with the rock when the material did not consolidate. That is, it was not converted to rock. The structures during this time that develops in the rock are known as primary sedimentary structures, and these structures are known as cover marks. And in some rocks, you have these flute-like features. How does it form? This is my pore animation. Suppose there was a black layer, okay, and the fluid was flowing towards you or towards the computer in this direction. It carried the bed load along and it covered the face. Then this yellow layer was deposited. So they will fill these scours as well. And when this rock will be preserved, they will have this mark on the bottom of this layer, or I should put it in a different way. When you see these features, these flutes, these are all flute-like things in 3D. So when we see these things, you immediately can say that the bottom was there in this direction. The direction of bulging, so bottom was in this direction. So these are flute cards. So basically flute mark. So this is basically a mold. This is not cast. Cast is base, and this was built by these things. Now again you may say, sir, again I have to believe you. You showed us a rock, and then you give us an animation. We believe you. So science is science. Your answer will be yes or no. You cannot have there's no question of believe or disbelieve. So you see, I'm sure that those who have visited the beaches must have seen these things. If you have a shell and water flows around that, you will see this power. Just remember, this flow, a laminar flow, because when it receives, you see the sheet-like water goes and it doesn't have much velocity. Still, how much cover it can make around that. And in the rock, you actually see the reverse thing. That is, the if a layer forms over it, then we use this cast to get this mold. Here you see that all the scar will appear as an elevated part. Sometimes these things are also preserved. So this is a horseshoe type of things. This is called current crescent. It looks like a crescent. And when you have these pillars in the water, same thing happens. You possibly know or be very careful when people go to the sea, many people break their hands and legs. Do you know the reason? Everybody wants to have a moderate blast of the waves. Fine. I'm standing here, wave is coming like this, I take the blast, and that is the pleasure. People shout all the time. Now, when the water recedes, just imagine this is your ankle. Suddenly, the materials are taken off all around your ankle, and you tend to fall in the reverse direction. And then, if you cannot balance yourself, then you fall in an awkward position, and that is the reason why many people break their hands and leg or get a pull in the ligament. So, what is advisable that while you take the blast, after that you start just keeping like this, so that your ankle, I mean the material behind your ankle doesn't lose material. Then that will tend to fall you, tend to push you in the reverse direction. So always do these things. Then you don't have any problem. But if you stay, because the back is in this direction and sea is here, so people look at the ocean. This is the normal thing. Nobody, when you go to the water, you don't look at the other side. You only look at the there. And this is the reason why many people, particularly the old elderly people, they actually fall. It's because of these things. And these are recorded in the rock. This is known as current cassette. And that is also the primary sedimentary rock structures. Well, now it is a rock, but it was formed when it was unconsolidated. Because if there is a rock, you cannot have a groove on this, and then whatever falls on that cannot form this thing. So we call it primary sedimentary structures. Well, is it okay for you, or if you have any question, you can ask? Well, I have taken a few sips water. Uh, I do not know in which year or in which semester you actually do this test, aberration test. In the building material, you must have heard this test. Have you heard this test? About this test?
No, sir.
Huh? Well, actually, Dory's aberration test, have you heard? Or maybe in some semesters, certainly, because that actually does the lab test for the material. So basically, the thing is, I will not intrude your subjects. I mean, those who are taught by your teachers.
Actually, we are in the third semester, so no, just lab subjects
Not
of
yet.
civil department are coming now. Yes,
Okay, okay,
only.
okay, okay, okay. So, I mean, the thing is, you will come to know this is the test everybody must learn. I will not get into the details because this is the headache of, this is the subject to be dealt by your teachers. I just want to extend whatever I have discussed rather than, the problem with the pipes, with the installations. Let me discuss the hardness for constructive reasons. So, how strong the material is? How do I know that? There is a test. Test is very simple. Uh, this is the most widely used aberration test of an aggregate, synthetic, natural, whatever. So, what is that? This machine is just like this. Very simple. It only rotates like this. Okay, the materials are poured through this. This lid can move up and you put the materials. So basically, what you do, you take a sample and you have mesh, and you can identify according to your requirement. You sort the size, and then you take the size and pour it here. Then you use the still walls. Okay. Then you press the button. The moment you press the button, it starts rolling, and rolling quite fast. 30 to 33 revolution per minute. At least 500 revolution is required. And then what you do, and what happens? I mean, if it moves, this ball moves and this also moves, they actually trying to crash this material against this wall and also make an impact on that. So what happens? Some weak people go away. They become fines. And then you use a size which is around, this is an international sieve size. I'm not an expert, but I just learned that it 1.7 millimeter sieve means, I mean, your particle will be more than 1.7 millimeter, the coarser one. So you sieve it out and you take the coarser one and you calculate the loss from the initial and final. This is very simple. And then you calculate the percentage of loss. And on the basis of that, you recommend a particular material. There are ISI standard, and I will not get into that. ISI standard that how much loss you can afford for a specific use. That's fine. So suppose it's 10% loss, well, you can use it for, construction of highway, because the load is quite high, rubbing will be more, so your material must be very strong. So this is how you make the test. Now, what does it actually do inside? How much material that will be lost depends on two primary things. One is the hardness of the material. Second is the crushing strength. I will not touch upon today. That is the compressive strength. So it makes an impact and it rubs these things against this wall. The classical way of measuring hardness. And then, you come up with the result. Now here, as a geologist or a material scientist, I just want to draw your attention to a point which I have written here. So how things work? A vendor comes and give you samples. Usually for road construction, you use natural materials, mostly basalts. In some cases, in railway, mostly basalts. So they come, they come with a sample. You do the test and you see, well, the material loss is small. You certify, the person goes away and brings the material. You instruct the people who are making this thing that use this material on this road. After 1 or 2 years, suddenly you see that the road is crashing. At least the material on the top are crashing. Then, well, there will be a furor in newspaper and these things. There are poor quality material, and you cannot hold the person because he has a certificate from you. This is a big social problem, I tell you. Why does it happen? You need to have this knowledge as well. You please visit the area from where these materials are coming. For my profession, I have to visit those parts. I do not see what happens when the road is constructed because my profession doesn't require that. But my profession does require that from where the material is coming and what is the nature of the materials. The third point in the first slide I discussed the chemical properties. In a query from where you take these things, if you visit a query, then you will understand the poor people are employed. I mean, they have amazing skill with this primitive hammer. They break the material in a particular size. I mean, for road materials, you cannot have differential size. They have a particular size. And in that case, if you look at the wall, you will see that the rocks are decomposed in different directions. And it changes the color. The moment the decomposition starts, the new materials form, they do not have the same color as the original. So in a fresh query phase, you can see these things. And certainly, if 20% of the query is made up of this degraded material, do you think the owner of this query will throw them away? When they send the sample to you, they will send the fresh samples. And you make the test. How much you can test? 5 kilos, 6 kilos? And you know how much material is required to make a road? And then these people come with the certificate and mix this stuff. What do you do? And when the load is on, the weaker part decompose or crushed, and the entire thing becomes fake. So please think about it, that you should have a look at the original material. If you see the color wise, this is heterogeneous, it is different, then please don't recommend. Please don't recommend. You should make the test for different color index of the material. We also collect samples from the quarry for our own work, and we carefully avoid those areas where the rock is decomposed but still very hard. We don't take those samples, but you really don't have much choice. So unless and until you understand what happens during chemical process and how does it affect the whole thing, all your endeavor will fall. So please don't take the test report as gospel truth. So you have to be careful about that. Finally, to complete the story, why this rock could make such a deep inroads within the marble? The reason is, you see the rocks. The rock has layer structures, layer after layer you can see, and for that you don't need geology. This is layer after layer after layers. What makes the layers? This is what makes the layers. You have marble and the layers of talc. You see the river's course. These layers are talc layers within marble. And you see river is coming, just following this layering, and then takes a turn. Why takes a turn? Because the layers also takes a turn. They follow these things. So basically, this was the bedrock over which the furious Narmada River flowed us and still flowing with all those coarse pebbles and sand-sized material, with this huge, velocity. It's just like a hot knife cutting through the butter. That is the reason why it could make such deep gorge. Everywhere where you see the peak, falls, for example, Niagara, is just like this scenario. It's marble. And that was limestone. It's not really, they don't have layers, but they have the same composition. Niagara is 98-meter fall, and here it is 32-meter fall. So, in both the cases, well, it is just like for Narmada, not for Niagara, because Niagara you don't see talc. Just like, watch is rubbing through, just hot knife through the butter. You see the watch. Well, talc is, this is a gorge made by people. Talc is used for different commercial purposes, including the making the artifacts. And that's why for centuries, people are excavating talc from these places in the banks of Narmada. And you see the gorge, man-made gorge. Again, you see the curvature because the layers are. So if the people can do this, what can a furious river do? You can imagine. So that explains why we have such a beautiful things. Thank you very much. This is part one. Bolo. If you have any questions, you can quickly ask. আরে তোমরা কি আছো? Are you there? Show some
Yes, sir.
sign of life.
Yes, yes.
Yes, sir.
Could I bring the right message to you? Think over it. I mean, I have
Yes, sir.
prepared. I have prepared the
Yes, sir.
material.
Very well, sir.
Okay, thank you. I mean, I have prepared a PPT with my extensive notes. If you want the literature, I can say, send those literatures. But many things are, it's my own imaginations. For example, you will not get any literature on Narmada. This Veragat area. But Los Angeles methods, hardness, cleavages is a standard thing you will find everywhere. But what is very important that how you will use that concept for your own skill. Okay, and particularly the Los Angeles operation test machine, and there are other machines, but that is not the issue. The science remains the same. You actually taste the hardness and the substrate. So hardness is an important parameter. That means bonding is the most important parameter. Deciding all the strength which is covered by your course, not my course, the entire civil engineering, other than the synthetic materials. Even then you have to think about it. Basically, it's the bonding. Okay, and I hope that I have not intruded to your course subject that much. And aberration test when you will do, I hope you will remember my few words. And particularly when you be a professional, this thing should be in your mind. The test report means nothing. You can be duped. The way you can be duped in purchasing the gemstones, you can be duped by these things. Sometimes you can stop, sometimes you cannot. But we should know what can happen. So কিছু একটা বলো ভাই, এতক্ষণ ধরে বকলাম। How was my picture from the beach?
Sir, the seashell picture was taken by you.
Huh?
The seashell picture was yours.
Yeah. Which picture?
The seashell pictures.
Oh
On
yes,
the-
of course, of course, of course. This is a color shell, and also that tree like surreal painting like cover. So, dear students, life has different shades. At the age of 58 plus, I have realized that using only one shade of light, different colors, and each color has different shades. So using only one shade of one color in a life is not good. It's not good. So don't only think about your profession, you should have a hobby. You should have some kind of hobby that will keep you alive, mentally alive. So doesn't necessarily mean that I'm pushing you to photograph, but whatever. You can listen to music, you can play instrument, to develop some habits. Otherwise, in a stressful world, it's very difficult to survive. Okay, Baba. With this, thank you very much. If you don't have any questions, I hope that you got my previous PPTs. Shobik, email, you did not respond. That you have got. Okay. Today I will send, or maybe tomorrow, I will send you this PPTs, and and just drop a word. Yes, sir, I have got it. Otherwise, I cannot decide that what is happening. Okay, I hope that you have registered your names. Eki, अरे
सर कुछ है?
अरे chat box है, देखो कारबार. So only one person responded.
স্যার কি অ্যাটেন্ডেন্স লিখতে হতো?
আমাকে লিখতে হবে? আরে তোমাদের জন্য আজ একটা কাজ করো, একটু তোমাদের ছেড়ে দাও, এখানে কয়েকজন আছে দিয়ে দাও, কিন্তু তোমরা যারা ছিলে একটুখানি আমাকে একটা লিস্ট পাঠিয়ে দিও, হ্যাঁ আজকে, কারণ ভাই আমার এটা দরকার না. I said that I don't care about this attendance. But I mean, if the university ask me that where is the attendance, that what shall I do? But at least those who are present, please record your part. This number refers to your class roll number.
Our university roll number the entire year.
Next day, if you want to arrange the CRs, the meet, then there will be no problem for meet entering the students.
Well, in the next class, one of you or both of the CRs will actually conduct the meeting, because you know that is little distracting for me to come back again. And I have to give entry to the person who are waiting for me. Okay. So next class day, please keep it in mind. Okay, you send me the link. So are you done with all the 24 candidates are done? Okay. Thank you. Bye bye. Have a nice time.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.